0. Well, this would be a demonstration, again, of an electrical force. What we have here is a pop can, okay, and aluminum, very light aluminum, and I'll discharge it to make sure, I'll discharge to ground to make sure there's no charge on this. And then here's our same old PVC tube again. Now, what I'm going to do is I'll charge up the PVC tube. Let me discharge it now, PVC tube. And when I put it close to the can, the negative charge on here will drive all the electrons inside the aluminum, drive the electrons to the other side. So this charged side of the aluminum can will become negatively charged, leaving the front face positively charged. So the positive charge on the front face and the negative 2 will attract. There'll be an attractive force here. And the negative charge here and here will be a repulsive force. But the positive charge here will have a greater force because it's closer. It's not as far away. This negative charge is farther away and the force is lower. So there should be the force on the front face going this direction is bigger than the force of repulsion on the back. So the aluminum can should move in this direction. And there's a force on it. So the force means it'll accelerate. Now, when we get to Galileo, a couple of weeks from now, we'll understand how a force makes a mass accelerate. It's F equals ma, actually, one of Newton's laws. So let's just do the experiment now. Without actually understanding what we're doing, we'll do the experiment. So here we go. I'm going to charge up our PVC tube again. Give it a nice charge. Again, the aluminum can is neutral. There's no charge on it. Okay. There you go. And so the aluminum can was attracted. In fact, it was even accelerated. Okay. If I were to keep it a constant distance away so that the force was constant, then it would accelerate at a constant rate. So let's do that again. Okay. Now, it's hard to measure accelerations, but when we do, look at the acceleration as a result of force, we can put a meter stick here, a ruler, and take a slow motion video. And with a little work, we can actually measure the acceleration of this mass. And the acceleration times the mass of this is going to be equal to the electrical force. So you can actually measure a force due to electric charge, okay? Which is what Coulomb did when he studied this, okay? And also I might say Benjamin Franklin played a very large role in electrostatics in the year 1750, which was 25 years before the Declaration of Independence. Benjamin Franklin was quite good at doing experiments like this. I find them actually, truly, rather difficult to do, but I want you to do them as good practice, and it's something, again, that children can do this, okay? So it's like, shall we say that this is, in some sense, it's like magic. You don't touch anything, but it starts to move. So how did that happen? That's like magic, right? What it really is electricity. Okay, so we'll continue then with discussing this in the lecture.